For decades, naval analysts followed a simple rule: improve what already works. Upgrade sensors, modernize weapons, refine the design, but avoid risky leaps that could cost billions. It's a cautious formula that shaped many successful fleets. But naval warfare rarely follows simple logic. In the early 2000s, the US Navy tried something radical with the Zumwalt-class destroyer, a futuristic stealth warship built for the wars of tomorrow. With advanced automation and a powerful electric system, it promised to redefine naval combat. Reality, however, was different. Costs exploded, priorities changed, and instead of becoming the fleet's backbone, only 3 Zumwalts were built. Now that experience shapes the Navy's next project, DDGX, the Future Guided Missile Destroyer. This time, the goal is balance, combining innovation with practicality. The real question is whether the Navy can build a ship ready for decades of technological change without repeating the mistakes of the past. A fleet facing the future. The US Navy is entering the second quarter of the 21st century with a fleet that spans multiple generations. Some ships are nearing the end of their operational lives. The Ticonderoga-class cruisers, once the centerpiece of American naval air defense, are now more than 40 years old. Many of the widely successful Arleigh Burke-class destroyers are also approaching the limits of their service life after decades of heavy use. At the same time, the Navy's most futuristic ships, the 3 Zumwalt destroyers, remain unique platforms rather than mass-produced fleet workhorses. The result is an urgent need for a new class of large surface combatant. This next-generation destroyer must meet several demanding requirements. It must serve well into the 2080s, carry advanced missile systems including hypersonic weapons, generate enormous electrical power for future combat lasers, and still remain affordable enough to build in meaningful numbers. These requirements were formally defined in December 2020, marking the official beginning of the DDGX program. But the program was not created because the Arleigh Burke destroyers failed. Quite the opposite. The success and limits of the Arleigh Burke. Few warships in modern history have been as successful as the Arleigh Burke class. First entering service in the early 1990s, these destroyers became the backbone of the US Navy's surface fleet. Their powerful Aegis combat system, versatile vertical launch missile cells, and adaptable design allowed them to perform a wide range of missions, from missile defense to anti-submarine warfare. Over the decades, the design evolved through several upgrades, culminating in the latest Flight 3 variant, which features the advanced Army-Navy SPY-6 radar. In fact, the Burke program has become the longest continuous production run of any US Navy surface combatant. But even the most successful design eventually reaches its limits. The Burke's original architecture was created for the technological realities of the 1980s. As new sensors, radars, and electronic warfare systems have been added over time, engineers have gradually consumed the ship's available space, weight capacity, and electrical power margins. For example, integrating the powerful SPY-6 radar required additional generators and cooling systems, pushing the design close to its practical limits. In other words, the Arleigh Burke remains an extremely capable ship, but its design no longer provides enough room for the next generation of energy-intensive technologies. That is where DDGX enters the picture. The Zumwalt experiment. To understand the design philosophy behind DDGX, it is important to revisit the Zumwalt program. Calling the Zumwalt destroyers a failure would be inaccurate. In many ways, they were technological pioneers. The ships introduced advanced automation, drastically reduced radar signatures, and an integrated electric power system capable of generating enormous energy. But the program also revealed how dangerous radical innovation can be when combined with high costs. Originally planned as a large fleet of stealth destroyers, the program was eventually reduced to just 3 ships due to escalating expenses. By 2026, each vessel cost roughly $7.5 billion, including research and development, nearly triple the initial estimates. Some of the program's most ambitious ideas also encountered unexpected problems. The ship's advanced gun system was designed to fire specialized long-range projectiles capable of striking targets deep inland. However, the ammunition became extremely expensive, about $800,000 per round. Procurement was eventually canceled, leaving the guns without usable ammunition. Other design features created complications as well. The unusual stealth hull shape improved radar invisibility, but introduced challenges in seakeeping and maintenance. Despite its enormous power generation capacity, around 78 megawatts, the ship lacked sufficient space for certain future weapons systems. The lessons from Zumwalt are now guiding the DDGX program. The goal is not to repeat the same radical leap, but to create a more balanced, adaptable warship. Designing the DDGX. The new destroyer will likely displace around 14 to 15,000 tons, making it significantly larger than current Burke destroyers. However, unlike the dramatic tumble-home hull of the Zumwalt, the new ship will return to a more traditional hull design with vertical sides. This approach simplifies maintenance, improves seakeeping, and reduces construction complexity. At the heart of the design is a new Integrated Power System 2.0. This system will rely on two Rolls-Royce MT-30 gas turbines, each capable of generating roughly 36 megawatts of power. Together with advanced battery systems designed to manage peak loads, the ship could have more than 30 megawatts of surplus electrical power available for sensors and weapons. That energy will be critical for the next generation of naval warfare. Future weapons such as high-energy lasers, advanced electronic warfare systems, and potentially even railgun-type weapons require enormous electrical output, something older ships struggle to provide. The DDGX is being designed from the beginning with this energy demand in mind. Weapons for a new era. Instead of specialized weapons like the Zumwalt's AGS gun, the DDGX will emphasize versatility. The ship is expected to carry a large vertical launch system capable of firing a wide variety of missiles. This includes air defense interceptors, cruise missiles, and potentially hypersonic weapons such as the conventional prompt strike system. Some concepts suggest extended launch cells capable of accommodating much larger missiles than current systems. In addition to traditional weapons, the ship is expected to carry 300-kilowatt-class laser systems for close-range defense against drones, small boats, and incoming missiles. In the future, these lasers could become part of a layered defense system designed to counter hypersonic threats. A laser might first disrupt a target's guidance systems before a kinetic interceptor completes the destruction. The destroyer will also feature the powerful SPY-6 radar, integrated electronic warfare systems, and advanced networking technologies that allow the ship to act as a central node in distributed naval operations. A networked warship. Modern naval strategy increasingly emphasizes distributed maritime operations, a concept where many different platforms share information and coordinate attacks across large areas. In this environment, the DDGX may function not only as a weapons platform, but also as a powerful computing hub. With enormous electrical capacity and advanced communication systems, the ship could process sensored data from aircraft, drones, satellites, and unmanned vessels. It may even supply power or recharge autonomous systems operating nearby. Rather than acting alone, the DDGX would operate as part of a networked fleet where information moves faster than weapons. Managing risk. Despite its promising design, the DDGX program still faces several risks. Technological delays could slow the development of lasers or hypersonic interceptors. Cost overruns might reduce the number of ships built. Industrial challenges, including supply chain disruptions or shipyard capacity limits, could also affect production schedules. To prevent the problems that plagued the Zumwalt program, the Navy has taken a more transparent approach. Design details are being discussed publicly, contracts include strict performance requirements, and budget oversight is far more visible. According to estimates from the Congressional Budget Office, each DDGX destroyer could cost roughly $3.1 to $3.4 billion, with as many as 28 ships planned by the mid-2050s. While still expensive, the Navy hopes the design will remain affordable enough for sustained production. What do you think about the DDGX destroyer and the future of naval power? Share your thoughts in the comments below, and if you enjoyed this video and want to see more content like this, make sure to like and subscribe.